In this demonstration, I'll show you how to find the derivatives of inverse trigonometric functions. This is part 1 of the series. In order to do this effectively, you will need to know how to use implicit differentiation, and I do have a video on that, so feel free to review that before you begin. Let's start with question number 1. In question number 1, they asked us to differentiate y is equal to the inverse sine function of x. So we'll start off by writing that down. And what we need is to find out y prime, or dy over dx. Now, since we don't know much about inverse sine functions, what we can do is to start off by converting it back into sine. So if we convert this back into sine, we end up with sine y is equal to x. Next, what we will do is implicitly differentiate both sides, the left and the right side. We'll start off with the left side. Sine y is cosine y dy over dx, and on the right side, x becomes 1. So what we just did is we implicitly differentiated the equation in terms of x. I'm going to increase the space here. And next, I'll isolate for dy over dx. 1 over cosine y is equal to dy over dx. Now, since originally our equation was in terms of y, and the fact that y is equal to sine negative 1x, let's replace this y with 1 over cosine sine inverse of x. And the next thing we'll do is set this as theta. So theta is equal to the inverse sine function of x. Now let's pretend that we took the sine of both sides. Sine theta is equal to x. And remember, in a right triangle, if we were to represent this as theta, and recall that sine is opposite over hypotenuse, this part over here would be x, and this part would be 1, because remember, x can be represented as x over 1. And in addition to that, if we were to solve for this side using the Pythagorean theorem, we would end up with 1 minus x squared square rooted. That being said, if we have 1 over cosine theta, we can use this triangle, and instead of using theta, of course, we can use what sine theta actually is equal to. Cosine relates adjacent over hypotenuse, so the answer to this becomes 1 over the adjacent over the hypotenuse, the adjacent being 1 minus x squared over 1. Therefore, our final answer is 1 over the square root of 1 minus x squared is equal to dy over dx. Let's proceed on to question 2. In question 2, they are asking us to differentiate the inverse tan function of 7x. The first thing you want to do is set this as y. Y is equal to the inverse tan of 7x. Now, once you've done that, we want y prime. So we will reverse this inverse function by taking tan of both sides, and that leads us to tan y 7x. Now we can implicitly differentiate. So we will differentiate this side, and we end up with secant squared y. And instead of using dy over dx, we will use y prime. And on the right side, the derivative of 7x is 7. Next step will be to isolate for y prime by dividing both sides by secant squared, 7 over secant squared y. Now keep in mind that y is equal to tangent inverse 7x, so let's replace that with that. 7 over secant squared tangent inverse 7x. And now what we will do is set this as theta. And I'm going to draw what I see here. What we have is theta is equal to tangent -1, 7x. We'll take the tangent of both sides, and we end up with 7x. Now, tangent is a relationship that compares the opposite and adjacent. So this number right here is the opposite. So this is 7x. And the adjacent is 1. So to find our hypotenuse, we would use the Pythagorean theorem, and what we would end up with is 1 plus 49x squared, all square rooted. So going back to this, we need to replace this whole thing with secant. Now if we were to use secant means 1 over cosine, and cosine relates the adjacent and the hypotenuse. Now it's the inverse, so it would be the hypotenuse over the adjacent. So hypotenuse is 1 plus 49x squared, all square rooted, and the adjacent is 1. So we end up with, as our final answer, 7 over the square root of 1 plus 49x squared. And since the secant is squared, remember that it was squared, this part right here, the square root, disappears, leaving us with 7 over 1 plus 49x squared. And there you have it. 2 complicated examples on how to differentiate inverse trigonometric functions. Stay tuned for part 2. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.